Today our learning goal is you will find the domain of a function. So you are finding the domain of a function. So back to yesterday. What did we talk about with domain? X values and its input. So that means when we're finding the domain of a function, what is it we're interested in? But what about it? What do we want to do with X values? Plug them in. So we're trying to figure out what? What'd you say? What I'm allowed to plug in. That's what it means whenever you're finding the domain of a function. We are looking for what I'm allowed to plug in for X. Because I'm not allowed, there are some things I'm not allowed to plug in. So what are some situations where I run into issues when I'm plugging something into a function? All right, but remember, we already know it's a function. So that we're not going to run into that problem. What do you got?
0 in the denominator.
There's number one. Okay, if I plug a number in and it produces a 0 in the denominator, that gives me a problem because we're not allowed to divide by 0. That's one. There's one more. There's one more issue we run into. Okay, and how does that happen? How do we get an imaginary number?
Square root of a negative.
There you go. And not necessarily just a square root. What type of root? What?
Even.
Even root. Okay, so those are our two things we have to be concerned about when we're finding domain of a function. Okay, what makes my denominator 0, and what makes an even radical negative on the inside? Those are the two things we need to be aware of whenever we're finding domain of a function. Okay. Now, a lot of people usually don't like this type of problem, but I can give you step-by-step way to do it. And if you follow my step-by-step way, finding domain of a function is very, very simple. Okay, so keep that in mind. You do it your own way, you're on your own. All right, so let's get started. I've got 1, 2, 3, 4, 5 examples I want to get through. And then we're done. All right, so here's my first one. I have f of x equals 3x over x plus 5. F of x equals 3x over x plus 5. So which one of my two issues do we run into on this one? Right, 0 in the denominator. Anytime you have a variable in the denominator, you need to be aware of what makes it 0 on the bottom. So in this case, what makes it 0? Negative 5. So what am I going to say my domain is?
Not negative 5.
All right, but I need to be a little bit more. It can be less than negative 5 as well.
Oh, yeah.
So what can I say about it? Okay, here's what I want you to say. I want you to say all real numbers except x equals negative 5. That's the domain of that function. So it would be all real numbers except x equals negative 5. Now, what would that look like if I wanted to put it in interval notation? What's the process? What's the process when I'm doing interval notation? What do I want you to do to get started? Leftmost number. So what's my leftmost number? Negative infinity is my leftmost number. Now, how many intervals am I going to have? I'm going to have 2 intervals. So if I'm on the left, Bree, what's my rightmost number of my left intervals? Nope. Nope. Negative 5. You're always, it can't be negative 5. So Bree, since it can't be negative 5, what am I going to put on that negative 5? I'm going to put a parenthesis, right? Because what does the parenthesis mean? I can't use it, but I can use everything up to negative 5. Okay? So I don't want to put negative 4 because there's numbers in between negative 4 and negative 5. I'm going to use the number, I'm just going to put a parenthesis around it, meaning I can't use it. Okay? So what's the other part of it? Very good. So it would be negative infinity or negative 5 to infinity. So that would be the domain if it was in interval notation. That tells me I can use anything I want to except for negative 5. Question on the first one. So if you just have something in the bottom, figure out what makes it 0, and then your domain is all real numbers except for whatever those values are. All right. Next one. Alright, I have the function h of x equals the square root of 10 minus x. H of x equals the square root of 10 minus x. So which situation am I running to here? I've got an even radical, which means I can't have what inside of it? Negatives inside of it. Alright, so what's my domain on this one? This one, some of you are going to be able to do it in your head. Some of you maybe not. I'm going to show you the way to do it if you can't do it in your head. Anybody have any thoughts on this one? What do you got?
It can't equal 100.
All right. Is that the only thing it can't equal? Huh?
Anything 11 or greater.
What about negative? What about 10.5? Anything greater than 10. Okay. So instead of saying x can't be anything greater than 10, let's talk about what x can be. What can x be?
It's equal to or less than 10.
Anything equal to or less than 10 is my domain on this one. Okay? Now, if you can't do that in your head, I'm getting ready to show you the process I want you to use anytime we're dealing with an even radical. Anytime you see an even radical, the first thing you want to do is take the inside and set it equal to 0. I always take the inside of an even radical and set it equal to 0. Then you solve for your variable. So in this case, I'm just going to add the x, and I get x equals 10. Once I get my numbers, sometimes you're going to get multiple numbers, but once I get my numbers, I'm going to produce a number line. Or I'm going to put it on the number line. And then I want to plug in on each side. I want to pick a number on each side and plug it in. So what's an easy number to pick on the left? 0. I always like to pick 0 whenever I can pick 0. So when I plug 0 in here, does that give me a positive or negative?
Positive.
It gives me a positive. So I let myself know this side is positive. What's the number bigger than 10? 12. I plug 12 in. What does that produce? A negative. So it knows everything on that side is negative. So which side am I allowed to have? I'm allowed to have the positive. So then all I have to do is talk about the left. So how can I say, we've already talked about one way. We can say x can be less than or equal to 10. So let's use interval notation. What would it look like with interval notation? Negative infinity to 10. Good. Okay, I know I've got to have a parenthesis on the negative infinity. What about the 10?
Bracket.
I can have a bracket. Why? It can be equal to, because if I plug 10 in, that's 0. What's the square root of 0? 0. So I'm good there. So I'm allowed to have it. So my domain is negative infinity to 10 with a bracket on 10. So if I have an even radical, what's step 1? Set the inside equal to 0. What's step 2? Solve. Step 3? Number line. Step 4? Plug in to figure out your signs, and then after you do that, you know which part of it is your domain. Okay? Pretty straightforward. Next one. Alright, I have g of x equals the cube root of x squared plus 4. G of x equals the cube root of x squared plus 4. What do we think? Say it again. Alright. She says set it equal to 0. You guys agree? She's asking. Do we set it equal to 0? What do you guys think? Do we need to set it equal to 0? Cameron says yes. Anybody agree with Cameron? Anybody disagree with Cameron?
I almost feel we leave it
Why?
because it's not in parentheses.
Go ahead, finish what you were saying.
Well, based on 36, it's a polynomial and you don't.
It could be anything, x, it still works.
Why?
Just because if it's say it's a negative number, it's going to become a positive, and then any positive number you could easily cube.
Okay, there's one way to look at it. There's another thing I can look at. What type of radical do I have?
Cube.
Cube root. Do I care about the inside of a cube root? No, because it's not an even root. So what is my domain to this? All real numbers. There are two things we look for. Variable in the denominator or an even radical. If you don't have those two things, what's your domain going to be? All real numbers. So this one is all real numbers. And I didn't mean for this problem to work out like he saw as well. He also saw that this right here is always going to be, the x squared is always going to be what? Positive, and a positive plus 4 will always be positive. So that's another reason why this one's all real numbers. Okay? But the main thing you need to see is this isn't an even radical, and it's not the denominator, so it has to be all real numbers. Alright, f of x equals the fourth root of x squared plus 3x. We have this one and one more to do. So f of x equals the fourth root of x squared plus 3x. Alright, Reagan, what do you think? What are your thoughts on this one? What do you see? What's the issue with it?
It's an even root.
There you go. It's an even root. Okay, and what do we do with even roots? Set the inside equal to 0. So that's what we need to see. We need to identify that this is an even root, and when we see even roots, we need to set the inside equal to 0. Okay? Now this one's not as easy as the one we did a couple minutes ago. This one requires a little bit before I can figure out what x equals. What do I need to do to this to figure out what x equals? Bobby, what do you think? What about you, AJ? What do you think? What do you got?
Divide by x.
Divide by x. All right, that's a good question. And that's something I'm glad you said that, because that's something a lot of us want to do. If I divide by x, I lose an answer. So I want to do something instead of dividing by x. What's another option?
Subtract 3x.
Don't want to do that either. Factor it, factor it out. There we go. That's what we want to do. That is something we're going to do over and over and over again in this class. Anytime I have to factor, the first thing you should be looking for is to see if there's something I can factor out. Okay, the number one rule in factoring is factor something out if possible. Okay, but we do not ever want to divide by a variable if we lose the variable. Okay, so if I divide it by x, I lose an x. So don't do that. Now that I've factored, what's my next step? Kendrick, what do you think? After I factor, what do we do? Try to solve this thing. Gage, what do you think? Once you factor, you set them both equal to 0. Okay, I can't do anything else to that one. That one's done. This one gives me x equals -3. So I've got my two numbers. So since it was an even radical, I set it equal to 0. I've now solved for my numbers. What's the next step? Number line. Good. You're going to think this is funny, but when I put my numbers on the number line, which one of those needs to come first? -3. Okay? You may laugh now, but somebody in here is going to do it. Alright? So now, in the last one, I only have 2 sections to check. How many sections do I have on this one? I've got 3 sections I need to check. Okay? So, a number over here on the left of negative 3. Negative 4. Now, whenever you have factored the problem, where you factored is where you want to plug in. And remember, when I plug a number in, I don't care what the number is. All I care about is what? If it is positive or negative. So don't think about an actual number. You're wasting brain time. Just think and figure out, is it positive or is it negative? So I'm going to take negative 4 and I've got to plug it into both pieces here. So negative 4 on the outside. Positive or negative? Negative. Negative 4 on the inside. Positive or negative? So negative and a negative gives me a positive. Okay, in between negative 3 and 0.
Negative 1.
Negative 1. So negative 1 on the outside. Negative 1 on the inside. Positive. So a negative and a positive gives me negative. And then on the right side of 0. 1. 1 on the outside. 1 on the inside. Which means this is positive. So which sections do we want? We want the outside sections. So let's look at the first section. How can I write the first section in interval notation? Very good. Negative infinity to negative 3. I know it has to have a parenthesis on the negative infinity. What about the negative 3? Bracket. Good. Okay, the next one. What's it going to be? 0 to infinity. Good. Parenthesis there. Bracket there. There's my domain. So that means if I plug something in between negative 3 and 0, what's going to happen? It's going to produce a negative, which means I'm getting imaginary numbers. But if I plug something in on the outside, what's going to happen? It's going to be positive, and it's going to give me a real number. Okay, so that's what's going on there. All right, one more. Alright, I have f of x equals 2x over the square root of x squared plus 3x minus 10. I'm interested in finding the domain. And what is it again I mean by finding the domain? What is it we're trying to find? What I'm allowed to plug in for x. That's what we're finding when we're finding domain. So what issues, what problems do I run into on this one? I've got two problems on this one. I got a radical, and it is located in the denominator. So I've got both issues on this problem. Whenever you have both issues, you want to focus in on the radical. Okay? Whenever you have both issues, you focus in on the radical. So what do we do to handle a radical? Set it equal to 0. So x squared plus 3x minus 10 equals 0. Now what? Now I want to factor. This one's different than the other one. What is it I'm trying to factor here? What is that thing called? It's a trinomial. And how do trinomials factor? Into two binomials. Good. So I know since this is a trinomial, it factors into two binomials. Alright, so I'm here at x plus 5 and I'm here at x minus 2. And let's talk about this because some of us are probably better than others in factoring. So I want to let you in on how I see this. Okay? Here's how I read this problem. I see factors of 10 subtracted to get 3. That's the first thing I read. Factors of 10 that are subtracted to get 3. Then I read it as, this tells me my signs have to be different. This tells me what my biggest number has to be. Okay? My signs are different. The biggest one has to be positive. That's how I read it when I'm factoring. So the first thing I do is I need factors subtracted to get this number. Okay? This tells me my factors have to have different signs. This tells me my biggest one has to be positive. That's how I read it. So if that helps you, have at it. Alright, hopefully we've learned that after we factor, what do? Set it equal to 0. Good. So I have x plus 5 equals 0. I have x minus 2 equals 0. So I'm going to get x equals negative 5 and x equals 2. Now what do I do? Number line. Excellent. Make sure you get them in the correct order. So -5 and 2. All right, so I need to check each section. So on the first section, what's the number I want to pick? -6, and where do we want to plug in at? Where you factored. So I factored right here. I need to plug it into each of these. So -6 on the first one. Negative. Don't think about the actual number, just negative or positive. On this one, so a negative and a negative
Positive.
means that section is positive. Between -5 and 2. Yeah, we better be picking 0. So 0 in the first one, 0 in the second one, which means I am negative. Then let's pick 3. 3 in the first one,
Positive.
3 in the second one,
Positive.
which means I am positive. So the interval for the first section is -5, parenthesis, and what do I put on the -5? Bracket. On the other one, to infinity, and a bracket. That's wrong. Why is it wrong? Why not? Right, what's different about this radical problem versus all my other radical problems? The radical is in the denominator. Anytime your radical is in the denominator, everything has to be in parentheses. So I need a parenthesis there, I need a parenthesis there. Okay? So if my radical is in the numerator, what are we using? Brackets. If my radical is in the denominator, what am I using? Parentheses. There's my problem. Now I want you to notice something. What do you notice about the number line of this one and the number line of the last one we did? Right, but that's not what I want you to notice. I want you to notice that it went from positive to negative to positive, which means my signs were doing what? Alternating. Okay? Whenever we do a problem like this, your signs will alternate except for when something happens. And that is, if one of these two was squared, anytime I see parentheses squared, my signs will not alternate. Or if I had an x squared that I pulled out, my signs will not alternate. So my signs will alternate every time unless I have a parentheses squared or I have an x squared by itself out front. So to save you some time, keep that in mind. So all I really have to do is figure out what one of these is and then do what? Alternate. So I can save some time there. So I can figure out which one of these would be the easiest to figure out. To me, the middle. Why? Because I get to plug in 0. So I always want to plug in 0. So in my case, if I'm doing this problem, I plug in 0, I figure out this is negative, and then I automatically know my outsides are positive. So as long as I don't have a parentheses squared or an x squared out front, they're going to alternate. If you do have a square, then you have to plug it in just like we did earlier today. Make sense? So that is finding the domain of a function. Again, what two things do we have to be concerned about? Radical. What type of radical? Even radical, and the other thing is variable in the denominator. If I don't have those two things, my domain is always all real numbers. Okay? Now, which one of those, now, some people, when we get into this, there's a lot more of the radical problems than there are just the variable and denominator problems. And you guys will get caught up because on a radical, we always have to do the number line. Okay? Keep in mind that if I don't have a radical, I don't have to do a number line. Okay? If there's no radical and there's a variable in the denominator, it's always going to be all real numbers except for whatever makes it 0. Okay? So if there's no radical, my answer is all real numbers except blah, blah, blah. If there's a radical, usually we put it in interval notation. Okay? So that's something to help you keep it straight. Okay? We've only got 4 problems. So you're probably, more than likely, some of us are going to get it knocked out before we get out of here.